Assalamualaikum warahmatullahi wabarakatuh, and very good day to all my dear listeners. Our group will present our assignment about conduction graphical analysis on heat transfer. This is our members group, which is we have HAZRIQ HAKIM, SMAIL, HARISHWAR, Conduction MOHAN, and me, ADIE ZULFIKRI bin MAZLAN. So about the assignment, in the study of heat transfer, fins are surfaces that extend from an object to increase the rate of heat transfer to or from the environment by increasing convection. As per the formula of convective heat transfer, the rate of heat transfer is directly proportional to the area exposed to the convective medium. Fins help to increase the area exposed to the circulating medium. So the objective to create two different fin surfaces according to our creativity using suitable design software. Perform heat transfer simulation process using suitable software on a fin surface. About heat sink, in technology, industry, and even natural systems, heat sinks are one of the most popular methods of thermal control. A heat sink is a component that helps to transfer heat away from a hot device. It achieves this by increasing the device working surface area and the amount of low temperature fluid that flows through it. We find a variety of heat sink aesthetic, design, and ultimate capabilities based on each device arrangement. How the heat sink works? First, it from source generate heat, then heat transfer away from source. Second, heat distribute throughout the heat sink, and last, heat move away from the heat sink.
Hi, I'm HAZRIQ HAKIM, and today I'm going to show you the analysis result for our assignment. So the diagram shows the analysis result for both design, which design 1 and design 2. Right, so we have set the ambient temperature approximately in between 28 degrees Celsius to 34 degrees Celsius. And for both design, the fin base size are all the same, which is 40 mm times 40 mm. So I have set the convection coefficient for both design, which 5.03, and the average temperature for cold side is 76.6, and the average heat flux on the cold side is 1500, and the average temperature on the hot side is 97.3. So as you can see, the design one shows the maximum temperature is 97.3 and the minimum temperature is 76.6, while the design 2 shows the maximum temperature is 97.3 and the minimum temperature is 76.3. As you can see, the hot side area will show the red color and the cold side area will show the blue color. And now for the discussion, so we have discussed the factor how to differentiate between the both design. First is the method of cooling. So one is a passive cooling. So passive cooling is a sink rely on the natural convection, meaning the buoyancy of hot air alone causes the airflow generated across the heatsink system. These systems are advantageous as they do not require secondary power or control system to remove heat from the system. However, passive heat sinks are less effective at transferring heat from a system than active heat sink. And the active heat sink is utilize a forced air to increase the flow rate across the hot area. Forced air is most commonly generated by a fan, blower, or even movement of the entire project, such as a motorcycle engine being cooled by the air passing along the heatsink fins designed into the engine. So the difference between passive heat and active heat, just like a free convection and forced convection. So passive is a free convection and active is a forced convection. So that's the size and shape of the fin matter for the heatsink transfer. The effectiveness of the fin is defined as a ratio of a heat transfer with a fin to the heat transfer without a fin. Heat transfer in the absence of a fin is by convection from the area, usually from the small area occupied by the fin. For a fin having finite length, the effectiveness increases with the length. So the more length of the fin, the effectiveness becomes the higher, according to the statement. So next is material of the heatsink. So why choosing the material is important? Choosing a material for a heatsink is largely depend on one factor: thermal resistance. Thermal resistance is the ability of heat flow to flow from a component into its surrounding. For example, the resistance from the component to its package. The package are to the adhesive material to the heatsink, and the heatsink to the air. When all of these numbers are added up, it will give an overall thermal resistance and help to understand what material should be chosen and how big the heatsink should be. Okay. And lastly, what is the importance of the heatsink in industrial and domestic use? Okay. Heatsink is important in a thermal management system in industrial and domestic, such as power plant, HVAC system, electronic system, and so on, because to provide an efficient path for a component or device in the system that produce heat to be transferred away, that means the heat must be rejected. It will reduce the temperature and make it the system process efficiently. And lastly, it also prevent the component of the device that produce heat do not work or broke down due to overheat, just like car engine. That's all from me. Thank you.
Hello, my name is HARISWAR and I am representing type of pin surface for our group for the heat transfer assignment. As you can see here, this is the type of pins common use in the industrial. For the first type is straight pins. The straight pins are generally arranged normally to the surface of the body and in parallel directions. For second is annually pins. The annular pins are annular shape fixed on the periphery of the cylindrical body. And for the third pins, radial pins. Radial pins are fitted on the cylindrical surface. And for the final type of pin is the pin fin. The pin fin is a lower cross section area. And for the next slide, for our second slides, we created a two type of fin design as the instructed in the heat transfer assignment. And as you can see on the slide, we have created a two type of these fin designs. For the first design, this is our own understanding. By creating this design, we are creating a design that has a tunnel for the airflow to flow. Where we, from our study, we increase the airflow inside the design. And for the second design, we use a commonly design that has been used for the CPU for the heat sinks. Yes, they commonly used in a general type of the heat sinks. And for the picture above, the diagram and dimension for our design. That's all for me. Thank you.
A very good day, sir. My name is HARISHWAR from BMMH3553. So today I'm going to explain about conclusion for this assignment. So from this assignment, we have learned the specification and characteristics of finned surfaces. We have go through many types of fin surfaces. So we have learned the specification, also characteristics, and also we have learned to do a selection of fin surface based on the size, material types, and also etc. Because for fin surface, we have to select a appropriate surface, appropriate fin type to fit on the device or anything, machine or anything. Then other than that, able to identify the importance of the heat sink in industrial and domestic, such as HVAC system, electronic system, and also so on. We also are able to use the appropriate software such as SolidWorks to design or create the variation of heatsink shapes and size based on our creativity, and also able to perform heat transfer simulation process from the design that have been created. And finally, we are able to find out types of heatsink, which are active heatsink and passive heatsink that applied in daily life. That's all we learned from this assignment, and this was so helpful. That's all from us, sir. Thank you.